Okay, so in this problem, we have to answer the following question. So we have to figure out how many words are possible given the following conditions. So we're making a three-letter word using these letters only. So in order to count within this kind of situation, we need to have two pieces of information. So first thing is, how many times do we have to choose a letter? So since it's a three-letter word, I'm going to have to choose a letter 3 times. So I have a first choice, second choice, and a third choice. And then I also have to think about how many choices, how many options do I have within each choice. And since I'm only choosing within these letters, that is 7 letters to choose from. Okay, so I'm making 3 choices, and I have 7 options within each choice, but really it's going to be affected by the specific kind of condition that we're working with. So the first problem says that there's no condition imposed. Okay, so that means for my first letter choice, I've got 7 options. So I have 7 possibilities for the first choice. Since no conditions are imposed, then for my second letter choice, I also have 7 options because there's no restriction on repeating a letter. And then for my third letter choice, I also have 7 letters to choose from. And then the fundamental counting principle tells us we can multiply the options across all the choices that we're making. And that's going to give us the total number of possibilities. So in this case, I have 343 words that are possible. Now the second condition, or the second problem, says that the condition is that no letters can be repeated. So what that changes, it changes the number of options that I have for my second and third choice. Since no letters can be repeated, that means once I pick a letter, whichever one it is, I have to take it out of my options for the next choice I'm making. So the next time I choose, there's only 6 letters to choose from. And then for the third choice, there's 5 letters to choose from. Now, of course, I don't know which letter I'm going to choose because it's random, but we do have to remove 1 letter at a time after we make a choice. Right. So, second count would be 210, because 7 times 6 times 5 is 210. Now, the third situation says that each word that you're going to make has to begin with the letter A. Okay, so that means since the first letter has to be letter A, there's only 1 letter A in our list of letters, so that means you only have 1 option for your first choice. However, it doesn't say that you can't, pick that letter again for the second and third choice. So then for the second and third choice, you have all 7 to work with. There's no restriction there. So 49 is your total in that situation. Because 1 times 7 is 49. The next situation says that the letter C must end the word. Okay, so that's very similar, except I have no restrictions on my first letter or the second letter, but I do have only 1 option for the last letter, which is letter C. Still 49 words possible. And then the last one, the restriction is that the second letter, erase my options here. So the second letter, that's this letter right here, has to be a vowel. Well, how many vowels do I have? A is a vowel and E is a vowel. So I have 2 vowels. That means for my second letter, I have 2 options to choose from, any of the 2 vowels. Then the first letter and the last letter, there are no restrictions there, so I can pick any of the 7 letters available. And then the fundamental counting principle says if you multiply all the options, that will tell you how many words are possible. So 98 words. Let's check our well. Okay, I'm going to check my answers. Had 43 words, 210, 49, and 49, and then 98